Thus far in these live lessons, we've learned what word vectors are, why they're so powerful across the gamut of natural language processing tasks, and the high-level theoretical considerations for how to generate them with the efficient word-to-vec algorithm developed by Thomas Mikaloff and his colleagues at Google. We're edging very close to implementing the word-to-vec algorithm ourselves in Python. But first, we need appropriate natural language data. In section 2.5 of my prequel live lessons, Deep Learning with TensorFlow, I described the most popular datasets for deep learning. As the prequel live lessons focused on deep learning fundamentals and the convolutional neural networks commonly deployed in machine vision applications, these datasets were all datasets of labeled images. For our NLP purposes, in these live lessons, none of those datasets is applicable. Instead of creating our own word vectors, an alternative option is to work with pre-trained word vectors that are available online. The Stanford NLP lab has made word vectors they trained with their GLOVE algorithm available here. Meanwhile, engineers at Google provide word vectors trained with word2vec here. If you're working with a specialized dataset, it can be advantageous. That is, it can lead to better performance on your specialized NLP application if you create your own vector space embedding instead of relying on word vectors trained on general natural language like the Stanford or Google word vectors just mentioned. In these live lessons, we will be training our own word vectors so that we have a solid understanding of how the process works, including the dataset cleaning that's required to obtain high-quality vectors. On my website, johncrone.com/resources, I maintain a resources page with a particular section on open data sources. So I will keep that up to date for you. We'll talk about some of the most useful data sources I've found to date for training with deep learning NLP models now. So you can check out this NLP datasets list that is curated in GitHub here. It does a really great job of summarizing the size, the date, the location, of course, and a short blurb about what each of these datasets are. And there's tons of them in here. This is a really, really great resource. Another great resource is Crowdflower. So Crowdflower have a business of labeling datasets, and they have conveniently made some very interesting datasets that they have already labeled available to the public in this Data for Everyone tab. You can, for example, search for sentiment in here. It comes up 41 times. And there are a whole bunch of datasets involving natural language in text. And these are split into classes. So here we have 13 different labels. So you could be training with that. And these data sets vary in size from thousands, hundreds of thousands. And so you can pick a size that's appropriate to the amount of time that you're willing to train a model for. Luke de Oliveira did another outstanding curation that is worth mentioning. Now, his curation is broader than just natural language processing data. So he has other data sets in here as well, computer vision, for example, but he's done an excellent job of summarizing some of the most valuable data sets with some useful icons, and again, size and links and a short blurb. So there are some brilliant natural language data sets you can pull in here. A paper that I absolutely love is this one by Zhang from Yalna Kuhn's lab at New York University. Now, at the time that they published this paper, there weren't very many large natural language processing data sets available, so they went ahead and made some. So you can see there is a table here in section 4 that covers these data sets, and they scraped them themselves and made them publicly available. I'll show you where that link is in a moment. So these range in size, and they're all on the larger size. These tend to be larger than the Crowdflower datasets, for example. One of the smart things that they've done is their training set is quite a bit larger than their test set. You don't need a huge amount of test data to test on, but it is valuable to have a huge amount of training samples. And you can see there are from hundreds of thousands to millions of training samples available across various classes. So let's talk about a couple of these a little bit. In these live lessons, we will be working on a lot of sentiment classification, and we'll be working with movie reviews. In here are two data sets, the Yelp review data set as well as the Amazon review data set, that are analogous to the data we'll be working with throughout these live lessons, except that these data sets are quite a bit larger. So the Yelp data set is an order of magnitude larger. The Amazon data set is 2 orders of magnitude larger. After working through these live lessons, I encourage you to download these data sets and work through the examples in these live lessons with them on your own time to get a sense of the rich word vectors and the impressiveness of the sentiment classification results that can be obtained from training with larger deep learning models trained for longer on larger data sets. With these larger data sets, you are more likely to find that deeper model architectures are helpful, as the nuance of the data can be represented in increasingly abstract ways. One cool classification model you could try to get started is downloading this full Yelp dataset. So there are 5 stars of reviews, from 1 star, which is the lowest rating you can give, up to 5 stars. And the authors conveniently split up the data into those 5 classes. Now, if you want to make the task a little bit easier for you initially, you can manually subset this full data set to only the 1 star, the lowest rating, and the 5 star highest rating data, ignoring the more moderate reviews, 2 star through 4 star. The author's polarity data set here mushes together the 2s in with the negative 1s and the 4s in with the positive 5s. So the 2 classes are a little trickier to distinguish in that polarity data set. You can add those 2s and those 4s into the negative and positive review data sets as a second step after you've created a great classifier that's distinguishing the 1 star from 5 star reviews alone. And here is the link for downloading those data. So the first author of the paper, he has provided the data here on his site. You can click in through here. So here's the name of the paper we were just looking at, and the datasets link is here, which brings you to a Google Drive, and all the folders are right here, waiting for you. We want to be able to train models quickly in these live lessons for the purpose of learning how to apply deep learning, so we'll be working with a relatively small natural language dataset. This will consist of reviews from 50,000 movies collected from IMDb, the Internet Movie Database. The canonical split of these data is into 2 equally sized groups, so a 25,000K training set and a 25K test set. So the authors who did this work were the authors of this paper, Learning Word Vectors for Sentiment Analysis. This is an illustrious team of NLP researchers from Stanford University, and this was a contribution to the Association for Computational Linguistics annual meeting held in 2011. To create their dataset, they selected a maximum of 30 reviews for films. So let's have a look at one of the films that's in there. This is a film called The Guardian, and they labeled any films that had reviews with 4 stars or less as a negative. So we can see some of those by filtering to the hated it selection. And they labeled reviews as positive if it had 7 stars or more. So those are the kinds of reviews that we see here in the Loved It tab. They selected reviews so that there are an equal number of positive and negative labels. That means that in the 25K training data, 12.5K are positive and 12.5K are negative. The same goes for the 25K reviews in the test data. In addition to the IMDb sentiment classification dataset, in these live lessons, to familiarize ourselves with Word2Vec and NLP best practices, we'll also do some pre-processing and perform some unsupervised learning with text pulled from Project Gutenberg. So Project Gutenberg has 54,000 free, mostly older books that are in the public domain because of expired copyrights. We'll work with 18 of these books in these live lessons, including some classics from Jane Austen and William Shakespeare. Finally, in lieu of using existing data sources for creating your word vectors, you may have proprietary natural language data, or you can scrape the web to create your own corpus. All right, excellent. So now we have the final piece of the puzzle for creating our own word vectors, the data. Let's get going on making our own vector space embeddings.